Welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. If you're new to the channel, please subscribe and click the notification bell icon for future updates. Let's talk about some updates in the AWS world. AWS WAF Bot Control is a new addition to AWS WAF or Web Application Firewall Service. As per the AWS Shield Threat Research Team, up to 51% of traffic heading into typical web application is originating from machines running scripts. These machines are called bots. There are a wide variety of bots. Some of the bots you want, some of the bots you don't want. They're hitting your endpoints, they're hitting your servers. Wanted bots are anything crawling to your site, indexing them, allowing you to make those websites available to the customer, discoverable to the customer, while others are monitoring for like site availability and performance. There are some bots that are using scripts trying to probe your applications for vulnerabilities or copying your content without your consent to another location. AWS WAF Bot Control can help you identify, raise visibility, and take actions against such kind of traffic. So using AWS WAF Bot Control, you can quickly integrate, add rules, and work with this particular managed rule. This bot control is integrated with Web Application Firewall and can be managed centrally using a AWS Firewall Manager for large enterprises. Bot control analyzes request metadata such as TLS handshake, HTTP attributes, IP addresses, just to identify the source and the purpose. It also categorizes bots such as what kind of bot it is. It is a scraper, it is a SEO, crawler, or just a site monitor. There are many benefits over here. They have like 5 benefits defined here. The key benefits that I would say is bot control gives you free visibility into the traffic that is coming. When you're using AWS WAF, you get a pre-built dashboard showing which application has high level of bot activity based on the sample data. The other key benefits I think is bot control reduces operational and infrastructural cost, because when you reduce the traffic of such scrapers, scanners, or crawlers, you can have better performance. Bot control blocks unwanted traffic at the edge before it can increase your application processing cost or can impact your performance. So that's a good addition to that. The last key benefit I would say is basically it is easy to deploy, because you can easily add a bot protection to your Amazon CloudFront, application load balancer, API gateways, or even AWS AppSync, just by adding a couple of managed rule group to your web ACL list. So it's easy to deploy, saves time. Pretty good service that AWS has included in this release. The next news is about AQUA. What is AQUA? AQUA is an acronym for Advanced Query Accelerator. It's basically a speed boost for your Amazon Redshift queries. As you already know, Amazon Redshift is pretty good in its performance. It is like 3 times better price performance than any other cloud data warehouse. Now, if you look at how AQUA works, is basically you have a high-speed networking layer between your S3 durable storage, and then you have a Redshift cluster. There is a number of compute nodes in the Redshift cluster, and AQUA sits in between the storage and the Redshift cluster. So it sits just below the Redshift cluster. And how is it designed? It is designed to scale out by having a parallel processing of subqueries. So there are parallel execution happening. Aggregation and filter results are returned back to the compute nodes. So when you send a query to a Redshift cluster, it goes and look how the subqueries can be further subdivided into parallel execution, which allows it to scale really nice and process that individual data of the query and get a filter and aggregator result. there are a couple of examples that I can share over here. Let's talk about what happens in Amazon Redshift. So when Redshift receives a query, this is basically a query here. It creates an execution plan like any other database does a plan. Then groups and scan aggregate operation on tables, determine which would be faster if sent to AQUA. So basically what is happening in this case, you have a select query, there are a couple of joins, and there is a scan filter with like condition over here. So this one as a subquery is sent to AQUA. So AQUA returns the result set, and then it is all aggregated. If you look at another picture of the same thing, it's saying the query comes into the Amazon Redshift cluster. The subquery is routed to AQUA, where parallel AQUA nodes basically process those subqueries, and then there is an aggregation that happens, and the result is returned back to the Redshift cluster. So those are the 4 steps that are happening in AQUA. It's a pretty good service. I think that will really boost up the Redshift performance. And if you look at it, there is only one switch over here to turn on or off, or you can just have an automatic where Redshift determines whether the AQUA is required or not. So you can, when you have a AQUA enabled cluster, then you can turn on, turn off, or make it automatic. Yeah, I think pretty nice blog by Jeff. This news is about discovering deleting incomplete multipart uploads to lower S3 cost. I didn't heard anything about multipart uploads that are still work in progress or still uploading. There are three step process that happens when you do a multipart upload. What exactly is a multipart upload? Basically, when you provide a file, that file is split into multiple smaller files, and those chunks are uploaded in parallel. And once all the chunks are available, it is again assembled as a single file that was uploaded. So these steps are mentioned here. The upload is initiated, the object parts are uploaded. Once all the object parts are uploaded, then it constructs an object from those uploaded parts. What happens when all the parts are now uploaded? What happens in S3? So basically S3 will keep those incomplete multipart uploads, which is like chunks of that particular file that you uploaded or the object you uploaded. If there are 10 slices of an object and only 5 are uploaded, those will be sitting in S3, and you will be billed for that. How do you know what is available, what has been uploaded, and what is sitting there for which you are billed? So S3 provides you a dashboard. Basically, if you look at it over here, basically you can see using the lens, storage lens. Under S3 you will find storage lens, and there will be a dashboard. Under that dashboard, basically you can select incomplete MPU bytes, and you will find like there are several bytes uploaded. And I was surprised to see there is a lot of data sitting there in my company's multipart upload S3 dashboard. It's a pretty good thing to know. You can basically set up a timeline. You can create a lifecycle rule. You can say if the multipart upload is basically sitting there for 7 days and it hasn't uploaded all the parts, basically using this rule, you can delete. You can set number of days. You can wait before basically deleting all these incomplete multipart uploads in order to save the cost. So it's a pretty good thing. I didn't knew that. It is a new thing that has been introduced recently. So it's pretty decent, or a problem that has been solved, which a lot of people are not even thinking about. It's really good on AWS part that we have received this service change. This is the end of the show. Thank you for watching. If you liked the content, please like, subscribe, and press the bell icon for future updates. This is your host Bhavesh Kumar signing off. Thank you.